Okay, what's now the homework? Quickly, so we can get through this. So it's on 1.2. At this point, the work problems aren't that important. I mean, do them, but it's very easy to watch other stuff. We're going to come back to word problems in like the end of chapter 2 and in chapter 3, and so we'll go over, translating sentences into math. Yeah. For now, I mostly put you on the algebraic stuff. So,
Go over 31. 31? Yeah, it's graphing. Y equals 1 over 2. Y equals 1 over 2. Brackets 1 minus cosine x. Yeah.
That's it?
Yeah.
Okay, so particularly in Calc 1, a graph like this is not terribly important for you to know how to graph. But especially when you get to Calc 2, being able to graph something like this is going to be important. So first we look at it like that. So the general rule is, if you have a graph that looks like A sine kx minus b plus c over A cosine kx minus b plus c, the numbers actually mean something. Absolute value of A is the amplitude. Right? It's how high it goes up. There's a baseline, and how much it goes up above that and below that is the amplitude. Your B is called the phase shift, which is just a fancy name for a horizontal shift. It tells you what number you shift to. C is the vertical shift, how you shift up and down. The period is 2 pi divided by k. And the so-called interval is the period over 4. So the thing is that you'll notice with sine and cosine, they sort of come in 4 different sections, right? So if you're graphing sine x, you can look at it as a grid that's split into 4 sections, where each section is length pi over 2. Right? And knowing what the graph does in each section tells you whether it's sine or cosine. So in the sine, it starts at the middle, then goes to the top, then goes to the middle, then goes to the bottom, then goes to the middle. Right? So you know that's sine. If you have a cosine, again you can split that into 4 sections. But the cosine starts at the top, then the middle, then the bottom, then the middle, then the top. Right? So that's the cosine. The idea is you want to graph exactly the same kind of picture, except these intervals will be different according to these formulas. Okay? So in this particular case, the amplitude is a half, right? The phase shift is 0, the vertical shift is positive a half. The period will be 2 pi divided by the k. The k here is 1. So the period is still 2 pi. And so the interval will be the same. It will just be 2 pi over 4, which is pi over 2. Which means you can do that grid. These are all broken lines. They're not a part of it. The amplitude is how high above, so you know that this goes to half, and it goes down to minus a half. This is still pi over 2, pi, 3 pi over 2, and 2 pi. And now you want to graph a negative cosine graph. So that's all you do. So everything flips upside down. So those are the points you hit. That's the graph. Sorry, we didn't do the vertical shift. Forgot this. Start over. Shouldn't take that long. First thing you do is the vertical shift. We shift up a half because of this guy. And then from there you do the amplitude. It will go up to 1, and then it will go down to 0. cosine, it's a negative cosine graph. Okay, that's it. Okay, so this guy tells you where the center line shifts to based on the C. And then the amplitude is the guy in front of the cosine, tells you how far you go up and down from that point. If there was a number here, we'll tell you how far you shift to the left or to the right. And the period would be this, which tells you how if it stretches or shrinks. Yeah, that's that. So if you want to graph that, for example, here you know the A is 3, the B is again 0, the C is 1. The period in this case would be what? 2 pi over the k, which is 2, right? So the whole period is pi, which means your interval is pi over 4. So you go to that graph. You shift up to 1, so that's your center line. The amplitude is 3, which means from 1 you go up to 4, and you go down 3, which means this will be minus 2. Again, we're going to break this down into 4 pieces. And the length of each piece is going to be pi over 4. So you know this is pi over 4, this is pi over 2, this is 3 pi over 4, this is pi. And you're graphing a positive cosine, which means you start at the top, with the middle, the bottom, the middle, the top. That's the graph. If you wanted to solve for these guys, then you'd simply set this equal to 0 and solve for this. So that's basically how we draw those. Other questions?
I was kind of lost how we got 2 pi over 2 and pi over 4.
Oh, from here, the formula is 2 pi over k, right? K is the guy that is the coefficient of the x. Here, the coefficient of the x is 2.
Okay.
So 2 pi over k is 2 pi over 2, which gives me pi. Then the interval, whatever the period is, I divide that into 4, because I know cosine sine comes in 4 sections. So I know each length is pi over 4. So this is pi over 4, pi over 4, pi over 4, pi over 4. And then I use that to construct the grid, and then you just draw the shape that you're supposed to do. Yeah.
Is it okay if I think of k as the amount of time, like say the cosine happens in 2 pi, like I would say?
Yeah, cosine 2x, you can think of 2 cosines happening in 2 pi, cosine 3x, 3 cosines happening in 3 pi, except in 2 pi, yeah. So, but a lot of the times you only need to graph one period, and also sometimes you can have fractions there, and then that concept can sort of confuse you. So it's not to just have a formula where you know exactly what lengths you want to cut things up into. Okay. Other questions?
It's not on here. My question is not on here. I just have a general question. So, like for the decreasing and increasing functions, is it only for the linear function?
No, any function can increase in numbers. And we are going to later on in the class determine when this happens. For example, in this function we can see we're increasing on the interval 0 to pi. We're decreasing on the interval pi to 2 pi. So any function can exhibit both behaviors at any given time. We're going to be determining exactly when this can happen without being able to graph the function even. So, but that's a general behavior of functions. There's nothing like. So it's not only a property of straight lines, any function can be increasing or decreasing. Or neither. Yes?
38A.
38.
Yeah.
Okay, what's that?
It said find the main of f plus 3, so it's radical 3 minus x.
Find the domain.
Yeah.
Okay.
So it's radical 3 minus
F of x is
yeah, radical 3 minus x. And
radical
g of
minus
x
x.
is radical x squared minus 1.
That's the g.
Yeah.
Radical of x squared minus 1 like that.
Yeah, the main of f plus g.
Okay, so f plus g is equal to what?
Just add it.
Right, you just add the two functions, right? So this is just, you want to find the domain of this guy. And you just, again, look at the restrictions for each part separately and then try to figure out where the overlapping is. So for this one, what does x needs to be here?
Greater than or equal to 3.
Higher than 3 or
You need 3 minus x to be greater than or equal to 0, which means your x has to be less than or equal to 3. What do you need here?
X squared minus 1 has to be greater than the,
X squared minus 1 has to be greater than or equal to 0, so what are the values where that happens?
so plus n minus 1. X should be greater than.
1 to infinity.
Less than less than or equal to negative 1 or like greater than.
It has to be greater than or equal to positive and negative 1.
Yeah, it has to be greater than or equal to 1 or less than or equal to negative 1. If you don't see that, what you can do is you can factor, just like we did yesterday. You get two answers, x equals 1, x equals negative 1. You put these on a number line and you just test the regions, right? So you test something like minus 2, you plug it in here, you realize you get 4 minus 1, which is positive, so that works. Plug in a number like 0, you get negative 1, which doesn't work. Plug in a number like positive 2, again, this works. So this works in these two regions here. So
Negative infinity.
again, you draw the number line and you're going to, so you know, it works, this one works here, going back, here, going forward. This one works at 3, going back. So now you want to figure out when they both work. So
It's negative infinity.
this 1, 1, 3. So for one function, you need all of this. And for the other one, you need this and that. Right? Now where do both of them work? You will see in this region, both lines are present. And in this region, both lines are present. Right? And so then this would be minus infinity to minus 1 inclusive, union,
Square bracket.
1 to 3. One thing to worry about here is in the case of something like f of g of x, the individual domains matter. Example, let's say I say f of x is 1 over x and g of x is the same. Then if I ask you what is the domain of f of g of x? Now when you take f of g of x, what would that look like?
1 over 1 over x.
It would look like 1 over 1 over x, which you'd simplify as x, right? And then that would look like anything will work, but really anything won't work because I have to worry about what the function was originally. 0 would not work here, and it still won't work here, right? Because it didn't work in the guy that you plugged in, it shouldn't work in the one that you would get the result, right? Because you couldn't have plugged 0 here in the first place. There's no way that you should be able to plug it in after you do some amount of trouble. Right? So the domain here for this x, even though it's a polynomial, would still be minus infinity to 0, union 0 to infinity. Right? Because you have to remember what the original is. You couldn't divide by 0 here, so you shouldn't be able to do it here. So sometimes you have to be careful of when you're simplifying, you might cancel things that you shouldn't cancel. Any other questions? You put your stuff away. for homework, take out a sheet of scrap paper and